All right, in this unit, we're really going to get into kind of playing with trig functions. You know how when we had algebraic expressions, we would factor or we would simplify. Logarithms, we'd use properties to condense or expand. We need to be able to maneuver with trig functions using identities to either simplify or do something with them. So we're going to practice that today. We're going to start with some really basic ones. So give me just a second. All right, so let's rewrite some of the things we've already known. So tangent. Tangent was y over x. Well, let's think about what y and x are on the unit circle. Well, if we think about this as y over x, y was related to sine over cosine. Cotangent was just a reciprocal x over y, so this can be rewritten as cosine over sine. Now, secant, secant was a reciprocal of cosine. It was 1 over x, or in this case, that would be 1 over cosine. It's a reciprocal of cosine. And cosecant was a reciprocal of sine, so this is 1 over sine. This one. So cosine squared plus sine squared. And this really means cosine. Here, let me show you. So think about our unit circle. X and y. On the unit circle, the radius was 1. So if we think about Pythagorean theorem, x squared plus y squared equals r squared, which in this case would be 1 squared. So that would mean cosine squared plus sine squared equals 1 squared, which it does. Now, this is actually what we're meaning, is that we're taking all of cosine and squaring it, but the notation we like to use is we put the square kind of above the cosine. Now, if you're putting it in the calculator, you would definitely have to do this. You would put the cosine in parentheses and then square it. But this is a really good property, and this is one of the few, these 5 I would have memorized before you go to calculus. These come up all the time. Now, we can rearrange this one, cosine squared plus sine squared equals 1, which is called the Pythagorean identity because it comes from the Pythagorean theorem. We can rearrange it to prove some of these other ones. So if I took cosine squared plus sine squared equals 1, and I divided everything, both sides, by cosine squared. So divided by cosine squared, divided by cosine squared. Let's see what would happen. I'd have cosine squared divided by cosine squared, which would be 1, plus sine squared divided by cosine squared. And then I had 1 over cosine squared. What is sine squared over cosine squared? Well, what's sine over cosine? Sine over cosine is tangent, so this is the same as tangent squared. 1 over cosine. Well, 1 over cosine is secant, so 1 over cosine squared is secant squared. So I can rearrange this Pythagorean identity to get me tangents and secants. I can also rearrange it by dividing by sine squared instead. And watch what happens. when I divide cosine squared by sine squared, and then I have sine squared divided by sine squared, equals 1 over sine squared. Well, cosine over sine is cotangent. So cosine squared over sine squared would be cotangent squared. Sine squared divided by sine squared would be 1. 1 over sine is cosecant, so this is cosecant squared. Now, all of these properties are on your formula sheet. We just got to play with them. And what I mean by play with them is a lot of times we are trying to reduce this into the simplest form we can. The easiest way to get started is to rewrite everything in terms of sine or cosine. I think that helps tremendously. So if I rewrite, if I look back at that previous page, cosecant, that's 1 over sine, minus cosine times tangent, and tangent is sine over cosine. Ooh, well, look at that. I kind of like that. What happens there? Well, notice I've got this cosine and a cosine here. These could cancel. I could also distribute sine. So I'd have sine theta times 1 over sine theta minus, those cosines canceled, I'd have sine theta times sine theta. Well, sine theta would cancel, and I'd be left with 1 minus sine times sine is sine squared. Now let's think back. I see that sine squared, and I'm like, I remember we had cosine squared plus sine squared equals 1. So what happens if I do 1 minus sine squared? Well, that would be like subtracting sine squared here. Cosine squared would be equal to 1 minus sine squared. So this reduces to just cosine squared, which is a lot simpler than what I started with. Now, I knew I ended up distributing, so let's distribute first on this one. I'm just going to do that for just funsies. And then I'd have cosine times cotangent. I'm going to rewrite everything as sines and cosines. So tangent was sine over cosine. Over here I have cosine. Then cotangent was cosine over sine. Okay, so in this first one, these cosines cancel, and I'm left with sine plus cosine squared over sine, because cosine times cosine would be cosine squared. Now I notice I've got a fraction over here, so let's turn this into a fraction. All right. Now if I'm going to add two things, they have to have the common denominator. So if I multiply this one by sine and the top by sine also, I will have the same denominator. So sine times sine is sine squared over sine plus cosine squared over sine. Once they have the same denominator, we just add our numerators. So I have sine squared plus cosine squared over sine. Well, sine squared plus cosine squared is 1. So I have 1 over sine, which is cosecant. And we've reduced it to one thing. That's awesome. Now let's look at this next one. It has secant squared minus tangent squared over cosecant. All right, so let's rewrite everything in terms of sines and cosines. So 1 over cosine squared minus sine squared over cosine squared. over 1 over sine. Well, in that numerator, I see that they have the same denominator, so I can subtract those two fractions. Well, hold on, wait a second. 1 minus sine squared. Well, hold on. Before I do that, if I'm dividing a fraction by another fraction, what we can do is multiply by the reciprocal. So I'm going to do that first. So times sine x over 1. But when I said, whoa, 1 minus sine squared, look what that was equivalent to. That's just cosine squared. Oh, these were supposed to be x's. Oh my goodness, I wrote thetas. Well, what happens here? Bam! And I'm just left with sine x. Feel free to try the next one on your own first and see what you come up with. I'll do it also. There are more than one way to do each of these problems. So what I'm going to do, I'm going to change everything to sines and cosines. Then I'm going to make this into a fraction, 1 over 1. So I'd have sine squared over sine squared plus cosine squared over sine squared. Now we would add those together. Oh, hold on. Sine squared plus cosine squared over sine squared. Well, what is sine squared plus cosine squared? That's just a 1. So I have a fraction divided by another fraction. So I'm going to have 1 over sine times the reciprocal of the denominator. And that's sine squared plus cosine squared, which is just 1. So I have sine squared divided by sine. We just get sine. Now, sometimes we can do something right at the beginning and make it simpler. If we look at our rules, I see that 1 plus cotangent squared is cosecant squared. So I could, and that's an alpha, replace 1 plus cotangent squared with cosecant squared. Now let's change it to sines and cosines. Cotangent was cosine over sine. All right, so if I multiply those numerator together, I'd get sine over cosine times sine squared, all over cosine divided by sine. Well, I've got a fraction divided by another fraction. So that's the same as taking this one and multiplying by the reciprocal of the denominator. And let's see if anything happens here. Well, that's just really sine squared. I'd have cosine times cosine times sine squared. Well, those just cancel. 1 over cosine squared, which would be secant squared. Last couple of examples. And I, on this one, would really like for you to try a few of the practice problems before you take a mastery check. To make them the same, I would need to multiply the top and the bottom by sine. Then we'd have the same denominator. So 1 minus sine squared over cosine times sine. That's just cosine squared. Cosine would cancel out with one of the cosines there. And that leaves me as cosine divided by sine, which if I look back at my identities is cotangent. Secant is 1 over cosine. This is 1 over sine over 1 plus sine over cosine. Okay, so I've got fractions, and I want to make everything, be able to add those two, so they need a common denominator. And I want to be able to add these two. So this one's easy. I'm just going to change that to be cosine over cosine. This one I would need to multiply the top and bottom by sine, and the top and the bottom by cosine. Okay. So I'd have sine plus cosine over sine times cosine over cosine plus sine over cosine. Fraction divided by a fraction. Keep. And flip. Be really careful here to make sure we're doing proper math and not killing any puppies. We can only divide out things that are being multiplied. This is a whole entity. Those match. Those can divide out. I cannot divide out this sign that's being added with a sign that's being multiplied. But the whole thing matches, so that can divide. And that would leave me with cosine x over sine x times cosine x. Well, again, the cosines would cancel here because everything's being multiplied. And I get 1 over sine x, which is cosecant x.